All right, so I just kind of wanted to get in the habit of making a video on the lesson that we just went over. So if you went over the lesson on the area of rectangles, parallelograms, and triangles, this is for you. So first page, we're basically going over, can you name the shape? And you can see here what we came up with in class for each of these shapes. Trapezoid actually is supposed to be down here, and didn't write that the best. And the characteristics of each. The main thing we're getting at, though, is this idea of area. And so for that, we're going to go to the next page. So we were given a parallelogram, and I showed how it is related to the rectangle. A lot of times we see the formula area equals length times width. The book likes to use the formula base times height, or B times H. And the only thing that changes when it's a parallelogram is the height. Instead of it being this side, it's going to be the perpendicular height. So it's how tall is this parallelogram. We found out both the rectangle and the parallelogram use the same formula. So to find the area of a parallelogram, you just multiply base times height. But again, make sure you're not multiplying it by this side length. You're looking at how far it is from this side to this side, and then the length from this corner to this corner. Base times height. And then they introduced this idea of altitude, which is really the same as height, which is why I put that little think bubble there. Altitude and height are basically the same idea. All right? So let's move on to the practice problems. To find the area of this rectangle, base times height, 6 times 2, which is 12 centimeters squared, is how we should label that. And then on the parallelogram, this is the base, this 11 miles, and then this is the height, so 11 times 6 would be 66 miles squared, or square miles. For triangle, we learned that the altitude is just from the top tip, or the vertex, down to the bottom. Okay, so it's like a mountain. Here's the altitude. How tall is that mountain from the sea level up to the very top? That's the same as height, just like it was with the parallelogram. Okay, and then we kind of fast forwarded over here. We looked at how a parallelogram and a triangle are related. If you double the size of the triangle, you form a parallelogram. So if you can use the base and the height to find the area of a parallelogram, if you cut it in half or divide by 2, you would get the area of the triangle. So the area of a triangle is 1/2 base times height. So then we practice that. Over here we kind of ran out of time. But if this is my base, okay, again, base does not always mean it's going to be on the bottom. Okay, this is one side, and this is the height. Now, technically, this could be my base, and this could be my height. Either way, we're going to multiply 6 times 8, and then divide it by 2. And here, we multiply 15 times 8, divided by 2, and we'd have the area of our triangles. Okay, and then the homework, look at this. We've got our formulas right here. Okay, in case you forgot, you didn't write them down. I need you guys to do question 2 and on 4, and this is on page 27 in your book. So again, think through how are you going to find the area of a parallelogram. All right, don't forget your label, don't forget your unit, and then how are you going to find the area of this triangle. Now keep in mind, which one of these would be the base? Okay, probably going to want to use this one. So if you turn the page around on the side, it might help you to see that a little bit. Yeah, hopefully that helps a little bit.